So section 13.10, Lagrange multipliers. Let's start with the first example. Use Lagrange multipliers to find the indicate extrema, assuming that x and y are positive. So our function is f to the xy. We have f to the xy equal x squared plus y squared. And we have the constraint is x plus 2y minus 10 equals 0. So our constant here is 0. So that means g of x, y is going to be x plus 2y minus 10. The next step, I'm going to find the gradients for f is going to be f sub x and f sub y. And here I'm going to find the gradients for g, which is going to be g sub x and g sub y. So the gradients for f is going to be equal 2x and 2y. And the gradients for g is going to be g sub x is going to be 1 and g sub y is going to be 2. Now, the gradients of f equal lambda, the gradients of g. I'm going to find two equations. That means 2x and 2y is going to be equal lambda, and the gradients of g is 1, 2. Then 2x is going to be lambda, and 2y is going to be 2 lambda. So this is the first equation. This is the second one. And the third one is going to be the constraint, which is x plus 2y minus 10 is going to be equal 0. So let's solve these examples, three equations to find x and y, and to find the extrema, indicate extrema by using Lagrange multipliers. So let's solve this one. This one is from the first equations. We can find that lambda is going to be equal to x. And I'm going to plug in this one on the second one. So plug in here, that means 2y is going to be equal to, and the lambda is going to be 2x. That means 2y is going to be equal 4x. So in this case, divide both sides by 2. That means y is going to be equal to x. So here is the value of y. I'm going to plug in the value of y here. That means with the third equations, x plus 2 times 2x minus 10 is going to be equal 0. So x plus 4x minus 10 is going to be equal 0. That means 5x minus 10 is going to be equal 0. Solve this one. So 5x is going to be equal 10. That means x is going to be equal 2. So I found the value of x. I'm going to plug in here. That means y is going to be equal 2x. So y is going to be equal 2 times 2, which is equal 4. So the value of y equal 4. Then that means f to the xy, which is 2, 4, is going to be equal 2 squared plus 4 squared, which is equal 4 plus 16, which is equal to 20. So we're going to plug in here the first one, f to the xy, which is 2 comma 4, and here we're gonna plug in 20. That's it for this example. Here we go, we got it right. Let's do the same thing with example 2. And example 2 is going to be, our function is 6x squared minus 2y squared. That means f to the xy is going to be 6x squared minus 2y squared. And our constraint is 8y minus 4x squared equals 0. Minus 8y minus 4x squared. Yes, that's right. That means our constant here is 0. So f of xy equals 6x squared minus 2y squared, and g of xy is going to be, let's flip this one because you're going to get confused. But you can say it's 4x squared plus 8y. So the gradient for f is going to be 12x and negative 4y. And the gradient to the g is going to be negative 8x and 8. So next step, what we're going to do next step is say the gradient for f equal lambda, the gradient for g, and then that's mean 12x negative 4y is going to be equal lambda negative 8x and 8. Then next step, you're gonna find the equations. 12x equal negative lambda. Let's write down the lambda negative 8x, and the second one is negative 4y equal lambda and 8. So we can solve this one. This is the first one. This is the second one. And the concentrate is, yeah, we can write down this, is fine. 4x squared equals 0. So from these equations, I can say lambda equal negative 4y divided by 8. Simplify it. So lambda is going to be equal negative y over 2. So here is the value of lambda. Now I need to find the x. I'm going to plug in lambda in the first equations. So from 1, which is 12x equals lambda negative 8x. So 12x equals lambda, which is negative y over 2 times negative 8x. Now let's cancel the denominator, which is multiplied by 2. So it's going to be 24x equal negative y times negative 8 is going to be 8yx. Move this one to the other side. That's mean 24x minus 8yx is going to be equal 0. Then factor out the 8x. The left here is going to be 3 minus y equal 0. Then 8x is going to be equal 0. That means x equals 0. or 3 minus y equals 0. So y is going to be equal to 3. So if you use x equals 0, that means when you plug in x equals 0, so when you plug in x equals 0 here, find the y. So it's going to be 8y minus 4 times 0 equals 0. That means 8. Y equals 0. That means y is going to be equal 0. So f to the 0, 0 equal 0. Go 6 times 0 minus 2 times 0, and this is going to be wrong. So we can't use this option. When lambda equal, when y equal 3, you're going to plug in a 3 here. That means 8 times 3 minus 4x squared equals 0. So 24 minus 4x squared is going to be equal 0. So 24 equal 4x squared. Divide by 4, that means x squared is going to be equal 6. So in this case, x is going to be equal plus or minus square root of 6. They're telling you on this example, consider that x and y are positive. So we can't take the negative 1. That means x is going to be only square root of 6. Y equal to 3. So f to the x and y 3 is going to be 6 times x, which is square root of 6 squared, minus 2 times 3 squared. So it's going to be 6 times 6 minus 2 times 9. And this one is going to be 36 minus 18. And the result is going to be 18. That means we're going to plug in here f to the square root of 6 and comma 3 is going to be equal 18. There we go, we got it right. Let's go to example 3. So example 3, use Lagrange multipliers to find the indicate extrema. And the same thing, here's the equations, but we have the constant rate, 6x plus y equal 300. So our constant here, c equal 300. That means f to the x, y is going to be 6x plus 6xy plus y. And g of x, y is going to be equal 6x plus y. So now the gradient for f is going to be 6, the derivative with respect to the x plus 6y. The gradient with respect to the y is going to be 6x, because this is 0, 6x plus 1. The gradient of the g is going to be, with respect to the x is 6, when the y is 1. Now the gradients of f equal lambda, the gradients of g, which is equal 6 plus 6y and 6x plus 1 equal lambda, 6 and 1. So now keep going. 6 is going to be equal lambda times 6 plus 6y is going to be equal 6 times lambda, the first equation. And the second one is going to be 6x plus 1 is going to be equal just lambda. This is the second one. That means from the second one, lambda we have is 6x plus 1. I'm going to plug in this one on the first one. So to plug in this one in the first one is going to be 6 plus 6y equal 6 times lambda, which is 6x plus 1. That means 6 plus 6y is going to be 36x plus 6. Now we're going to solve it for y. Minus 6 from both sides. That means 6y is going to be equal 36x. Divide both sides by 6, so y is going to be equal 6x. This is the value of y. Now plug in this one in the constraint. I forgot to write down the constraint here, which is 6x plus y equal 300. I'm going to plug in y here. So 6x plus y, which is 6x, equal 300. That's mean 12x equal 300. So x is going to be 300 divided by 12 is going to be 25. That's mean y is going to be 6x, which is equal 6 times 25, which is equal 150. So y is 150, x is 25. So f to the 25 and 150 is going to be 6 times 25. 6 times 25 plus 6 times 25 times 150 and the plus 150. Let's plug in everything in the calculator. So 6 times 25 plus 6 times 25 times 150 plus 150 is going to be 22800. So it's going to be 22800. So let's check these. So f to the 25 and 150 is going to be 22800. That's it for this example, example 3. We're going to do the same thing with example 4, but we have the constraint and we have f, x, y, z, 3 variables. So example 4, use Lagrange multipliers to find the indicate extrema, and x, y, z are positive. So minimize this one, and the constraint is x plus y plus z minus 18 equals 0. So here is the function f of x, y, z, and now g, the constant is 0. G to the x, y, and z is going to be equal x plus y plus z minus 18. So now the gradient for f is going to be, with respect to the x, 2x, to the y, 2y, to the z is going to be 2z. And the gradient for g is going to be 1 for the x, for the y is 1, for the z is 1. Now the gradient for f equal lambda. The gradient for G. So let's work on these. That's mean 2x, 2y, and 2z is going to be equal lambda 1, 1, and 1. So let's work on this one. 2x is going to be lambda, the first equations. 2y is going to be lambda, this is the second one, and 2z is going to be equal lambda, this is the third one, and the constraint, which is x plus y plus z minus 18 equal 0. Now let's solve this one for the lambda. That means x is going to be equal lambda over 2. I'm going to solve this one for the y. So y is going to be equal lambda over 2. And I'm going to solve this one to the z. So z is going to be equal lambda over 2. Plug in these three and the constraint. So lambda over 2 plus lambda over 2 plus lambda over 2 minus 18 is going to be equal 0. I'm going to find the value of lambda. By the way, you can solve the system as you like. It's fine. So I solve for x, y, and z, and I plug in here to find the value of lambda. Now, the same denominator, so it's going to be 3 lambda over 2 minus 18 equals 0. Then I'm going to multiply by 2. That means it's going to be 3 lambda minus 18 times 2, which is 36, equals 0. So in this case, lambda is going to be equal 36 over 3. That means lambda is going to be equal to 12. So we're going to go back here. X is going to be 12 over 2, which is 6. Y is going to be 12 over 2, which is 6. And Z equal 12 over 2, which is also 6. So we found the X, Y, Z. That means F to the 2, 2, and 2 is going to be equal 2 squared plus 2 squared plus 2 squared, which is equal 4 plus 4 plus 4, and this one equal 12. No, it's a 6. Why I put 2? So 6, 6, and 6. That means it's going to be 6 squared, 6 squared, 6 squared. So it's going to be 36 plus 36 plus 36, which is equal 108. That's it for this example. Let's check that. Here we go. We got it right. 666 equal 108. Let's jump to example 5. We're going to do exactly the same thing. For example 5, we have, so here's our function f(x,y,z) equal x times y times z, and the constraint here, our constant here is 0. That's mean g of x, y, z is going to be equal x plus y plus z minus 9. Then the gradient for f is going to be, with respect to the x, with respect to the x is going to be y, z. With respect to the y is going to be x, z. With respect to the z is going to be x, y. And the gradient for G is going to be 1, 1, and 1. Let's check. X plus Y plus Z equal minus 9 equals 0. That's right. Now, the gradient for F is going to be equal lambda the gradient for G. That's mean X, Y, Z, X, Z, and X, Y is going to be equal lambda 1, 1, and 1. So Y, Z is going to be equal lambda X, Z is going to be equal lambda, and Y, Z, X, Y is going to be equal lambda. So we have on the constant rate, it is X plus Y plus Z minus 9 equals 0. So let's try to solve this one. The first thing, from the first one and the second one, we can find that from this one, I can solve it for the Y. So Y is going to be equal lambda over Z. And from this one, I can solve it for X, X equal lambda over Z. Let's try to plug in these two here. Okay. Plug in these two here. So it's going to be X, which is lambda over Z, plus Y, which is lambda over Z, plus Z minus 9 equals 0. I'm going to multiply everything by Z to cancel the denominator here. So it's going to be lambda plus Z squared minus 9Z equals 0. I still have lambda. I can solve it for two variables. But let's check here. From the third one, xy. So xy equal lambda. That means lambda over Z times lambda over Z equal lambda. So it's lambda squared over Z squared equal lambda. Multiply everything by Z squared. So it's going to be lambda squared equal lambda Z squared. Move the lambda on the other side of this one. Okay, divide both by lambda. That means lambda is going to be equal Z squared. So I'm going to go back here and plug in here. It's going to be Z squared yes, because this one is going to be Z squared plus Z squared plus Z squared minus 9. Z is going to be equal 0. That means 3Z squared minus 9Z equals 0. So we're going to factor out 3Z. That means it's going to be Z minus 3 equals 0. So 3Z equals 0. That means Z equals 0. If you plug in this one here, everything is going to be 0. So we're not gonna use this option. The second option, Z is going to be equal to 3. If Z equal to 3, that means lambda equal Z squared which is equal 3 squared and equal 9. So lambda equal 9, I can find y and x. X is going to be equal lambda over z, which is equal 9 over 3 and equal to 3. And y is going to be the same thing, lambda over z, which is equal 9 over 3 and equal to 3. So in this case, x3, y3, and z3. That means f to the 3, 3, and the 3 is going to be equal 3 times 3 times 3 and equal 27. That's it for this example. Let's plug in here. 3, 3, and 3. And here we're going to put 2, 7. Here we go. We got it right. Let's move to the last question, question 6. So with the example 6, here's our function. We have 2 constraints. That means it's going to be 3 gradients, g and h, lambda and mu. So the constant here is 28, and the constant here is 16. So I'm going to write down here g of x, y, z equal x plus y plus z. And I'm going to write down h to the x, y, z. I need space. So our function is f to the x, y, z is going to be x, y, z. And now g of x, y, z is going to be x plus y plus z. And h to the x, y, z is going to be x minus y plus z. So here's the 3 equations. I'm going to find the gradient for the x, for the y, and for the z. The gradient for f is going to be, for the x is going to be yz, for the y is going to be xz, and for the z is going to be xy. The gradient for g is going to be for the x is 1, for the y is 1, for the z is 1. And the gradient for h is going to be 1, -1, and 1. Now we're going to use lambda and mu. That means the gradients for f is going to be lambda, the gradients of g, plus lambda, the gradients of h. That means yz, xz, xy is going to be equal lambda 1, 1, and 1 plus mu 1, -1, and 1. So let's write down the equations. That means yz is going to be equal lambda plus mu. This is the first one. Xz is going to be lambda minus mu. This is the second one. Xy is going to be lambda plus mu. And the first constraint, which is x plus y plus z equal to 28, and x minus y plus z equal 16. So we're going to solve these 4, 5, from 1 and 3. Lambda plus mu. These are equal. That means yz is equal xy. Move xy to the side. So yz minus xy equal 0. Factor out the y. So z minus x equal 0. That means y equals 0 or z minus x equals 0. That means z equal x. Y equals 0. That means this one is 0. This is 0. X times 0. So everything is going to be 0. And this doesn't make sense. It's not going to be extreme. So I'm not going to choose the y equals 0. X equals z. Let's plug in x equals z in the constraint on the first one. That means it's going to be z plus y plus z equal to 28. And the second one is going to be z minus y plus z is going to be equal 16. So this one is going to be y plus 2z equal to 28. And this one is going to be negative y plus 2z equals 16. Cancel these. So 4z going to be equal 44. That means z is going to be equal 11. So z 11. So x is going to be equal z. That means x is going to be equal 11. So x 11 and z 11. We're going to plug in here to find the y. That means x plus y plus z equal to 28. So 11 plus y plus 11 equal to 28. So 22 plus y equal to 28. That means y is going to be 28 minus 22, which is equal to 6. So we found x, y, and z. That means f to the x and y and z is going to be x times y times z. And this one is going to be equal 11 times 6 times 11 is going to be 726. Let's check this one. The last example. So it's going to be 11, 6, 11. And here 7, 2, 6. Here we go. We got it right. That's it for this section.